Welcome, ladies and gentlemen. So what I'd like to do is show you how to graph the secant as well as cosecant function. And when graphing these, basically the main important thing is, one, identifying what the parent graph looks like, but also understanding what is the reciprocal function. So here I have y equals cosecant of x, and you can see that's going to be your blue graph here. But what's important about this, what I kind of drew with this dotted line, is you can see this is also the graph. I drew in the graph of the sine function, because to graph cosecant, basically, they're the reciprocals, the reciprocal functions of each other. So the graphs are very much related, where you can see wherever the sine graph intercepted the x-intercept, that was when the y was equal to 0. Well, since it's the reciprocal, you can't have 0 in the denominator. So therefore, it's going to be undefined for cosecant. So every single time you can see where the sine graph crosses the x-axis, now that creates asymptotes. And remember, asymptote is going to be where our graph is going to approach. In the same respect, instead of the graphs opening up, they're going to be opening away. So you can see here the maximum is now turned into the minimum of this little kind of U-shaped formula, where here is the minimum is now turned into kind of like the maximum point of that arc. All right, it's not actually the maximum point, because you can also see that these graphs are going to expand indefinitely up and expand indefinitely down. But it creates something that's very, very interesting, that basically if we can graph the sine graph, then to really convert it to cosecant, all we simply have to do is wherever there's intercepts, draw asymptotes, and wherever the max and the min is just kind of draw little parabola curves going in the opposite direction and approaching the asymptotes. But before we can get into that, we have to make sure we identify the period, which is exactly the same. It's going to be 2 pi, just like sine and cosine, determining the x scale as well as the phase shift. Now, in these two examples, what I did is I chose two problems that are going to have a change in period. Now, it's also another important thing to understand here is the other thing important is the amplitude. So we have a's here. Now, again, a is going to affect our graph, but you can see that we don't have an amplitude. Remember, amplitude is the half distance, right? Well, these graphs extend indefinitely up and down, so therefore there really is no amplitude. However, the amplitude we know affects the sine and the cosine graph. So if I'm only going up to 1/2 and down to -1/2, that means this graph is also going to be vertically condensed. If I'm going up to 2 and down to -2, that means these points are going to be farther away from each other. So A still is going to affect it. We're not going to have an amplitude. We don't need to figure out the amplitude. However, it is still going to affect our graphs. So the best way I like to do when getting into these problems is really to forget that we are graphing cosecant and secant, and just graph the reciprocal function. So the reciprocal of cosecant is going to be sine. The reciprocal function of secant is going to be cosine. And you can see exactly everything I talked about over there is exactly true over here. OK, so let's go ahead and get started. Now remember, we don't need to worry about an amplitude, but we do need to figure out the period, which in this case is going to be 2 pi divided by b. Well, b in this case is going to be 1/2. Right? Remember, there's a 1 in front of the x, and that 1 is being divided by 2. So therefore, we have 2 pi divided by 1/2. To solve here, I'll multiply by the reciprocal. So the period is 4 pi. To find the x scale, remember, we just take the period divided by 4. So 4 pi divided by 4 equals pi. There is no phase shift. So we know our initial period is going to be starting at 0, and there is no vertical transformation, so we know we're going to be good for there. So basically, let's see here. Well, I guess maybe I should show you this way. Basically, what I would recommend we do here is think about this as graphing 1/2 sine. Actually, I'll do this in a different color. So if I was going to graph this as y equals 1/2 sine of x divided by 2, all the information that I just found is exactly the same. But with the sine graph, though, we would need to figure out the amplitude, which is the absolute value of a, which is absolute value of 1/2, which is 1/2. OK? So the only reason why I kind of mention that is because even though we don't have an amplitude for a cosecant, knowing the amplitude is going to be important for the sine graph, because that's going to tell us where these points are going to be located. So let's go ahead and graph this, and we'll do 2 periods going to the right. So since the amplitude of the sine graph is 1/2, that means if here's 1 and here's down to -1, that means my graph, the maximum point's only going to go up to 1/2 and down to -1/2. And again, we're starting at the y-axis here, so that's going to be 0. So what I like to always do is just graph. I like to go ahead and graph the sine graph, and then use the sine graph to help me graph cosecant. So again, though, we can still identify the x scale and the period is still going to be the same. So we'll have 1 pi, 2 pi, 3 pi, 4 pi, pi pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. Because we're going to do 2 periods, in case you didn't already figure that one out. That's usually what I like or ask of my students to go ahead and do. Now, so before I go ahead and get into this, let's go ahead and do what the sine graph would look like. Well, the sine graph, we know it start at 0, at least the initial period, minimum, intercept, or maximum, intercept, minimum, intercept. Here's one period. And I'm going to dash this because it's actually not a part of the graph. We're just using it as an aid to help us graph cosecant. X, intercept, minimum, intercept. OK, so now basically when I want to go ahead and graph this, now what I do is I basically go wherever there's an intercept, I am now going to create an asymptote. So you just go to the graph, and you just go to all the intercepts.
Rosa, can you please come to the main office? Rosa, can you please come to the main office?
Then, wherever there's a maximum or a minimum, I know that's also going to be a point on my cosecant graph. And then, remember the graphs have to approach the asymptote, so I'm just going to try to draw little curves here, approaching each asymptote. Okay. So there you go, ladies and gentlemen. That is how you graph the cosecant. Now let's go ahead and get into secant, where secant is going to be exactly the exact same thing that we just did, but we'll try to move it along a little bit quicker. So here, in my period, I'm going to have 2 pi divided by pi, which is just going to be 2. My x scale is going to be 2 divided by 4, which is 1/2. And we found that. Then the other thing we need to do is figure out our amplitude. So again, we're going to want to look into graphing y equals -2 times cosine of pi x. Well, we want to figure out the amplitude. So the amplitude would be the absolute value of -2, which is 2. And that's just important because now my scaling on my y-axis is going to go up to 2 and down to 2, right? These maximum points and minimum points are going to be at +2 and -2. The other important thing I want to make sure that I remember here is that I have this negative sign. So I'm going to actually be doing a reflection. Remember, then when your a is negative, you're going to be reflecting about the y-axis. So first of all, though, we can do a lot of this stuff without actually, I'll do a period to the left and a period to the right, just so we can get practice doing both. So if I was going to do a period to the right, I'll at least just do the x scale. So here is 1/2. 1, 3/2. Period is 2, right? Yeah, 1/2 and then 2. So then this would be -1/2, -1, -3/2, -2. Okay, so the graph hasn't been shifted left or right at all. So we know our initial period is still going to start at 0. But instead of going up, instead of having our max and mins at 1/2, I'm now actually going to have to go up to 1, up to 2, down to -1, down to 2. Okay? Now, typically, the cosine graph started up here, right? You can see this cosine graph starts here in the initial period, intercept, minimum, intercept thing. So it looks something like this. Well, now, actually, let's so you had a point here, point here, point here, point here, and then a point up here. Okay, so that's typically what this graph would look like. But now we have this negative. So now we're going to be reflecting all of the points. So instead of being up here, it's going to be reflected over the y-axis, so it's going to be down here. This point at the intercept is going to remain the same. Instead of being down here, that's being reflected up to our maximum. That remains the same. And this goes back down to your minimum. So actually, the cosine graph is going to look like this. Then, if I just continue with my pattern here, intercept, max, intercept, min. OK? So now that I've graphed the cosine graph, and you don't always have to use all of these, but I just wanted to show you, well, here's what the green is what it should look like. The negative made me reflect it over, and then I just continued a period to the left and just another period to the left instead of 2 to the right like I did here. So just like we did with the cosecant graph, we're going to do the exact same thing. Wherever we see the graph intersect the x-axis, that is going to be a asymptote. So I just come in, and I just create asymptotes. Now, these asymptotes are a little bit different than the other dashed lines. The other dashed lines were just aid to help us graph, where the asymptotes are actually a part of our graph. They're going to be in blue. They're actually going to be a part of our graph because that is where our graph is going to be approaching. Then, for every maximum and minimum, those are going to be points on the graph. And then I'm going to have them approach the asymptotes. OK. And there, oh, I guess I got another one over here. So there you go, ladies and gentlemen. That is how you graph the cosecant as well as the secant graph when you have a change in period. Thanks.